Goodbye to old theories. A bold new explanation for dark matter is about to revolutionize science, and it all starts with superconductivity. What if the universe's greatest mystery has been hiding in your local hospital's MRI machine all along? Dark matter makes up 85% of everything in the universe. Yet we've never actually seen it. Much like Roman philosophers once imagined we were made of tiny particles, we're still piecing together the universe's biggest puzzles. We only know it exists because without it, galaxies would spin apart like pizza slices in a centrifuge. It's the invisible glue holding everything together, but nobody knew what it actually was until now. Physicists from Dartmouth College have just proposed something brilliant. They think dark matter started as massless particles zooming around after the Big Bang, but then something extraordinary happened. These particles began pairing up, like puzzle pieces finding their perfect match. Physicists call these massless particles Dirac fermions. When they pair up, it's a lot like how electrons form what's called Cooper pairs in superconductors, letting them move without resistance. Here's where it gets fascinating. When particles pair up this way, they slow down and become heavy. And we've seen this exact behavior before in superconductors, where electrons pair up as Cooper pairs. This is the same physics that lets MRI machines work so efficiently. You know, the technology that makes MRI machines work without losing energy. In superconductors, electrons do something completely unexpected. Instead of repelling each other, they pair up and glide through materials with zero resistance. The new theory suggests early universe particles pulled the same trick, creating the dark matter we observe today. What makes this theory revolutionary isn't just its elegance, it's testable. Unlike past ideas that relied on exotic particles, this one is surprisingly simple, and, best of all, it's testable with data we already have. If this theory is correct, the process would leave subtle traces in the cosmic microwave background, the faint afterglow of the Big Bang. Scientists can look for these patterns in data we already have. If these physicists are right, this pairing process would have left subtle fingerprints in the cosmic microwave background, the faint afterglow of the Big Bang. But this theory doesn't just explain where dark matter came from. It could also reveal how the early universe shed its energy and evolved into the cosmos we see today, that we can still detect today. So the universe's greatest mystery might not be so mysterious after all. So why should you care if you're not wearing a lab coat? Because this idea links the mysteries of space to the same physics that powers your hospital's MRI machine. It could be the same physics that's quietly working in hospitals and laboratories around the world, just happening on a cosmic scale. If it's right, dark matter isn't made of magical mystery stuff. It's just particles doing something familiar in a very unfamiliar place. And if it's wrong, well, it's still a wild idea worth talking about. Whether this theory stands the test of time or not, it's a bold idea that pushes science forward. And that's always worth talking about.